Hi, in the last video we discussed about using an observer to observe an element, an HTML element, or let me say using an observer to observe a node. And we gave an example here where we created an observer instance using the new mutation observer, the mutation observer constructor here, and we applied it to a UL element. And we also discussed about using various options to determine what type of change the observer is going to monitor on the particular node that we pass to the observe method. Now in this video we are going to be discussing about we are going to be talking about how to manipulate the change, or let me say how to handle the change that occurs whenever the observer actually reports a change, because obviously what the observer has to do is to handle the change, because what it does is to detect the change, and when it detects the change like that, it actually returns an object to us, or an array of objects. Let me say that because I'm going to explain it now. So it returns an array of objects to us which we can manipulate to know what type of change has taken place and where the change took place and other stuff like that. But before we start, if you haven't subscribed to this channel, kindly subscribe to get updates from me and click on the notification bell. Also, if you haven't watched the last video, you can check the description of this video. Hopefully I'll remember to add the link there, and if it's not there, you can always search for it here on YouTube so you can find it. And thank you for understanding. Now in this video, as I said in the last video, that we're going to be discussing about how to manipulate these the values returned to us by the observer whenever it detects a change. As you can see, we have new mutation observer here, which means we are creating a new observer instance. And I said before that this observer actually takes in a function as its parameter, like that, which is this function that we have passed here, and the function starts from here like this up to this point here, up to this point. Now it is inside of this function that we have the capability to handle the change and do whatever we want. So for now, let me clear everything we have in this function, because I've not explained it. Yeah, I've cleared that. So the next thing I have to do is to actually, the first thing that we have to do whenever we want to handle a change, if actually we are going to be making use of the array passed to us by the observer, because the observer is one that will determine what type of object will be passed to this function. As you can see here, we have mutations. Now generally, whenever we are creating an observer like this, now I want to explain the concept from the beginning. We pass in a function to the constructor like this, which is this function, and the function takes in two parameters. They are not compulsory though. You can remove them and still maybe just console log if you are not actually concerned with whatever the array contains or something like that. So the function we pass to the constructor takes two parameters, not has to take, because it's not compulsory. So it takes two parameters. We can either put the parameters there if we want to manipulate them, like we want to check and do things with them, and if not, we can just omit them. As you can see here, we have this here, and this is telling us that the mutation callback here takes into parameters. The first one is mutations, which is going to return a mutation record object. Array of mutation records. As you can see, this here signifies an array, and it is telling us that it is an array of mutation record. This mutation record is actually it is an object, and it has certain properties in it that we can read which is going to tell us about the change that was detected. And the second parameter here is the observer, and this observer here is going to represent which observer actually called the function, like the current callback function that we are running. So that is useful if, for example, we want to use multiple function. Maybe we want to define the function outside like this. Let's say function callback, something like this. So if we are defining the function like this outside and we want to include it in the observer, it's going to be useful, because when we pass mutations like this, I'm going to clear this. Now when we pass this observer here, so to this constructor, let's say we have more than one observer on this page. This one is one instance of the observer, and we can also create another observer by saying const observer2, like this. So if we have another observer here, which is new mutation observer again, so if we also have another observer here and we want to use the same callback function for the two, so to detect which one is actually calling the function out of the two, we can access this observer here to know which of the two observers is calling the two. But here we are using just one observer, so there is no need. So let me just undo everything here. Now here we have passed inside this function, we have passed the first parameter, mutations, and as I said before, this is an array of mutation record objects, and the mutation record object is an object that contains certain properties which gives a description of the type of change that was detected by the observer here. Now mutations, and the second one will be observer. We can just omit this if we want, but let me just leave it there like that. Or let me, since we are not making a reference to it, let me just remove it. So I've removed the observer parameter there. It's not compulsory, but I hope you get the idea behind it. Now for us to actually access the mutation record objects that are inside of this array, bear in mind that this one will be an array. Whenever this function is called, the first parameter here will be an array. So to access the objects, an array of objects, now to access the objects inside, we have to loop through the array, either by writing a for loop like so. We can say for mutations, we can just say let I be equal to 0, I is less than mutations dot length and I plus plus, like this. I plus plus, then so we can loop through the mutations array like this, because this is an array of mutation objects. So to actually access each array of mutation records, so to actually access each mutation record, we have to loop through the array like this, but usually I don't use this method. So we can just say mutations dot for each, like this. We can just say function mutation so we can just use the for each. I prefer this, so we're going to be using this for each. And if you don't know what for each means, for each is a method of the mutation of any array. You can call for each on any array, and this one, since it is an array, we can use for each on it. So for each is going to automatically loop through each of the elements in the array that is calling the for each, and it's going to run this particular function that we pass to it for each and every one of the elements. And the first parameter that we pass here represents which element we are currently on. So let's say, for example, the array is like this. So if it is 2 and 1, for example, and we call for each on this array, so for each is going to loop through this array and then call this function for each and every element. and whatever the first parameter I will pass to it will represent the element that we currently are on. So if it is the first loop, then this mutation is going to be 2. After it runs this function for the first item here, so after it runs the function for the first item, it goes over to the next item, which is 1, and mutation will be 1 by that. I'm just giving an example here. So that's how for each works. Now for each mutation, remember that we are using for each now, so this mutation is going to be one mutation record object. So this mutation is an array of mutation records, and by using for each, we are getting each value of the mutation record objects. Now let's discuss it. Let's discuss the mutation record object. The object has certain properties that we can read to detect, like to know what type of change has taken place, where it took place, and we can also get other details about the change by reading the properties of this mutation record object, which is represented by mutation here in our case. Now, how do we do that? How do we access the details and how do we get the type of change that has taken place? The first parameter, the first property, I'll say it's the most useful kind of, but depends on which one you want to use. So the first property that we are going to be discussing is the type property. So for example, let's just say console.log mutation.type, like this. Now what does the type property return? The type property returns the type of change that took place, and can only be either child list, this child list here, or attributes or character data. Any of the three. That's what type is going to be equal to. So mutation.type, remember that this mutation here is an instance of mutation record, because as I said before, what the first parameter that we pass to the function that we include in the constructor is an array of mutation records. So we are now looping through each and every one of these of elements in the array, and we are representing each item with this mutation. And remember that each item in this case will be an object, because this one is an array of objects. So each item in it is an object. Then we can now access the properties, mutation record object. So we can now access the properties of the mutation record object, of which one of them is this type here, and that is why we can say mutation.type. Now the type returns the type of mutation that has taken place. So for now, let's go into the browser and let me remove this here, or let me just comment it out like so. So it's now commented. Now we want to see what type of mutation, what type of change was detected by the observer. Remember that we have set child list to true, attributes to true, and character data to true here. So it can be any of the three now. So let's go on into the browser. Let me refresh. Now we have this. If we check the console, there is nothing here at the moment. And remember, if you are actually following through this tutorial on your desktop, you can just preview it in the browser the normal way you preview HTML in your browser. So it doesn't have to be like, I'm not explaining how I'm previewing it in the browser because I'm using a mobile device. So like that. So right now we don't have anything in the console because we haven't made any change to this UL here. Remember that we actually added the observer to the UL. Now let me make a change. Let me just put Y here, nosy. Now we should be expecting the type to be character data, because we actually changed the character data. I explained what character data is yesterday. I said yesterday in the previous video. So let's come here. As you can see, we have character data here, which is the type of change that was detected by the observer. And that's just one. If I hit enter like this, we have created another element here, another li. So another change must have been detected by the observer, and what we should be expecting here is child list, because child list is the one that indicates that the editor, and is the one that indicates that a new node has been added or removed from whichever node that we added the observer to. And now I've just added a new li. So we should get child list in the console now. As you can see, we have child list here. It's even 2, maybe because of something that has happened, I don't know. But as you can see, we have child list here, which means that the observer has actually gotten it, that we made a change to the, we added a new node to the UL. So let's go back to the editor now. So remember before that we actually commented this part out, and what this set timeout does is that it changes the ID of the UL. Remember that the UL is what we are referencing with this list lm, because we got it here, query selector UL. So if I uncomment this and then preview in the browser again, so let me refresh now. After 5 seconds, we should be expecting something here. Let's see. As you see, attributes, because we set the timeout that after 5 seconds the function is going to make a change to the ID of the UL, which is why we have these attributes here like that. So let's go back to the editor and move to the next property that we can read. Now, apart from the type property that we can read, we can also check out the target. So let me just change the type to targets now. Now, what does this target return for us? By accessing mutation.target, we want to get where the change took place. That's it. Now, if the change is child list, remember that child list means we want the observer to monitor the element, the node that we pass here, for changes in its child nodes. So child list means we want to listen for changes in child nodes. So if at all a new node was added or an existing node was removed, then the observer is going to fire this callback function that we have here, and the target is now going to be the parent, like the element whose child node has increased or decreased. In this case, it will be the UL, because we can only change the number of elements that are in the UL. We have 2 LIs by default, as we specified here in the HTML. We have 2 LIs. This is the first one and this is the second one. So when we make a change to the number of LIs there, then we can actually get that, okay, the target is now where the change has occurred, which is going to be the LI in case of child list, when the type is child list. Also, when the type is attributes. So one thing to notice is that whenever the type is child list or attributes, the target will be an HTML element always. But if the type is not one of these two, if it is character data, then the target is going to be a text node. Like that. So let's actually log into the console the target for now. And here too, I want to change list lm dot, let me say dot query selector dot query selector. I want to select the li. Now dot id, we are changing the id of the first li in the UL after 5 seconds. So when that happens, we are going to log the target to the console. And also, when we manually change the number of children in the UL, we are also going to log the target into the console. Remember that it is the UL that contains the LIs. So let's go to the browser and see what's happening. Now the first thing we want to see is, let's focus on this console. Now as you can see, we have li id list lm because we are changing the id of the li. Remember the set timeout, you can go back to check it. We are setting the id to list lm, and this one here, this li is an HTML element, and the reason is because we are changing the attributes. And I already said before that when the type is attributes, then the target is going to be an HTML element, so always remember that. And here we have all of these things here, as you can see. So this is an li like that. Now another thing I want to do is I want to change this one from being nose to nosy like this. We should have logged something into the console. I mean, there should be something in the console right now apart from the li that we saw there before. And as you can see, we have text, bold text, assigned slots, and other stuff like that. And this one here is not an HTML element because the type of change that was detected here is not attributes and it is not child list, it is character data. And I said before that when the type is character data, remember that character data is when there is a change in the text like this one. So when the type is character data, we are not going to be getting the target to be an HTML element. It's going to be a text node, which is why you have this here. So as you can see, we have all of these things. You don't have to focus on this, so just know that. So we just have to know that this thing here is a text node like that. So yeah, now I want us to take a look at something here. We have a UL and we have two LIs. So when I click on enter like this, enter, the first thing is that in the console we should have another target again because another change has taken place. So I'm coming back to the DOM here. As you can see, we have this UL again, UL telling us that UL with the ID of my list content editable to true is the one that is representing the target of the last change that we detected. And if we check the DOM, we are going to see that the UL now has three LIs, 1, 2, and the third one has ... because there is nothing inside it, which means we have actually added another LI here like that. So let's go back to the editor. So now we are back in the editor. So we are going to discuss more about, not discuss it again, but I think we are going to create a simple project at the end of this tutorial here. Now the next property that we'll be talking about is the added nodes property and the removed nodes property. Now added nodes and removed nodes. When we say added nodes and removed nodes, the added nodes property, it returns a list of nodes that were added to the target. You know, the target is the node where the change is taking place. Now the added nodes property returns the nodes, a list of nodes. So the added nodes property returns a list of nodes that were added to the target, and if nodes were removed, it will return a list of nodes removed from the target like that. So how do we do that? Let's just say for now we want to check, and remember that added nodes and removed nodes, they are going to be null. They're always going to be null except if the type is child list. So they are going to be null if the type is not child list. So they are always going to be null if the type is not child list. So when the type is now child list, we can now access added nodes because there'll be something there, maybe added nodes or removed nodes like that. So let me say if type, so to get the type here, in this case I can just say const type like this is equal to mutation. Now don't get confused if you don't know what this is. This is called object destructuring. By writing this this pair of brackets here, curly braces, this pair of curly braces here, it means that inside of this object, because this one is an object, we want to access the property type. Assuming we put added nodes here, it's going to access mutation.added nodes. But because we put type here, we are accessing mutation.type. So whatever mutation.type is going to be stored inside the type variable. So let's continue like that. I think that's understood. It's very easy to understand it. Now we can now say if type is equal to child list. So if the type is child list, then we can now run this code here. And what's the code? We want to say console.log mutation.added nodes like this. And also want to log console.log mutation.removed nodes. So what this is going to do is that if the type is child list, remember that if the type is not child list, added nodes and removed nodes, they are going to be null, or sorry, they are going to be empty. I made a mistake there. They are going to be empty. So if the type is child list, which means a node has been or more, so one node or more have been added to the target or removed, that is when the type will be child list, because child list indicates that there is a change in the number of child nodes of the target. That's what child list is about, and we've discussed about we've discussed it here before. Now if the type is child list, we are logging mutation.added nodes to get which nodes were added. We are logging that into the console, and if nodes were removed, we are also logging it into the console. So if, for example, nodes were added, we are going to get it here, and this one will be empty because no nodes were removed. And if it's the opposite that actually happens, maybe we removed a node, added nodes is going to be empty, and removed nodes is going to contain the nodes that were removed. So let's see what happens there. Let's go into the browser. So we are now in the browser. Let me refresh, and let's see. At the moment there is nothing in the console, and we are never going to get anything in the console, because even after, we defined a set timeout at the end of the script, but that's actually changing the attributes. It's not changing the number of nodes in the UL or anything like that. So by ourselves, let's create a new node. When I hit enter like this, a new node has been added. So when we check the console, as you can see, we have this node list. The thing about mutation observers is that you cannot specify, you cannot predict the number of times they are going to report the change. There are some times that you make just one change and the change is reported twice, but with certain simple differences in the two reports. So you cannot just say, okay, it's going to be just one because of one change. There are times that you make just a change and the observer returns to it gives two reports. So that's it. Now, as you can see here, You know, we're actually logging added nodes, removed nodes. So this one is added nodes, removed nodes, and this one too is added nodes, removed nodes. Now, because we actually added because we actually added a new node, added nodes is taking has one item here. You know, this is a node list, a list of nodes. So we can just see 0 HTML element, which means it has one item here. If we check the prototype here, let's check the length. As you can see, length 1, which means we have one item there. So we have one item inside of this node list, and the one item is HTML element, which we can check out here like this. So the removed nodes, in this case, the length is 0, as you can see, because we did not remove any node. Remember that the first one is added node, and the second one is removed node. This one is added nodes. As you can see, HTML BR element. You know, the browser automatically adds a BR element inside the li tag that we created here, because there is nothing inside it, so it's going to put a BR tag inside it. So let's check the DOM and see what's happening there. As you can see, you know, we did not add a BR by ourselves. It was just this ID list lm tongue li nose, and the li that we added last, the browser automatically added this BR that we have here, and that is why we are getting this one too here. As you can see, BR element. As you can see, BR element like that. So, which is another added node. This time the target is not going to be the UL. The target is going to be the li, this li that was added here, because this BR was added in this li. So this BR here was added in this li, and this li was added in the UL that contains this one. So if we check the target for this one, it will be the UL, and if we check the target for this one, it will be this li that we added last here. So I hope that's understood. Now let's go back to the editor. So I hope that explains added nodes and removed nodes. The next properties that we're going to be talking about is previous sibling and next sibling. Previous sibling and next sibling. Now, just like you probably would have guessed that before, previous sibling returns the previous sibling of the target, and next sibling returns the next sibling of the target. So it's very simple. Previous sibling and next sibling. So let me clear this. Now, as I said before, previous sibling, it returns the previous sibling of the target. Let's say, for example, let me come into this HTML. For example, we change this one from nose to maybe NOS. We remove the E. So the target is going to be, the target is going to be this text node here. This text node here. And now let's say, for example, we made a change to this li, not the text inside it this time around. Or let me just say we have this UL here. In fact, let me say it that way. This UL here, this UL, if we make a change to these LIs, like this one here, if we make a change to it, the target is going to be this UL, and I think I just made a mistake. I'm very sorry for that. The previous sibling and the next sibling, they return the previous sibling and the next sibling of the added or removed node. I made a mistake there. The added or removed node. So let me explain that again. I'm very sorry for that. I made a mistake. So we can say mutation dot previous sibling like this, and what this is going to return to us is the previous sibling of the node that we added or the node that we removed. That's it. So let's say, for example, we are going to test this out now. And how do we do that? We are going to remove this li here, this nodes li. We are going to remove it. Then when we remove it, we want to get this li before it. This is going to be the previous sibling, since this is the removed node in this case. If you don't understand what I'm saying, let me say it again. To test this out, I said previous sibling and next sibling. There are two properties of the mutation record object. As I explained the mutation record object before. Now, the two properties, that is previous sibling and next sibling, they return the previous sibling and the next sibling of the added or removed node or nodes, in case there was more than a node removed at the same time. So to test it out, I now said we are going to remove this li in the browser, not here. We are going to remove the li, and then we want to get this previous sibling, which is going to be this li here. Let me give it an ID of first like this. Now let's come back to this main.js. Let me comment this out and back to this place here. You can now say, to make sure that the previous sibling is actually not going to always be null or something like that, we want to check the type, because if the type is not child list, previous sibling is always going to be, I think, null also, but we are not going to get any value there. It's either null or I think it's going to be null. So it's going to be null. So to make sure that it's not always null all the time, we want to check if the type is child list. And remember that I actually removed the definition for type here, so let me just add it back. Const type like this is equal to mutation. Now if type is equal to child list, if type is equal to child list, then we want to log into the console the previous sibling. Say console.log mutation dot previous sibling, like that. So what this is going to do is that whenever the observer detects a change, because we're actually listening for many changes here, we're listening for change in the child nodes, in the attributes, in the character data, and like that. So we want to filter out when this console login is going to take place. So if the type is child list, that is, if a node was added or removed, because child list here, as I explained in the last video, is going to make the observer listen for changes in this element here, for changes in its child nodes. And if subtree is also true, and here subtree is true, so it's not going to just listen to this list element, it's going to also listen to the descendants of this list element for changes in the number of child nodes they have. I explained that in the last video. If you don't understand, you can just go back and watch the video. So if the type is child list, that is, if a new node was added or removed, then we want to see the previous sibling. If it doesn't have a previous sibling, it's just going to be null. So let's go into the browser and see what's happening. Now let me refresh here, and now I've just refreshed it. So as you can see, there is nothing in the console at the moment. So even if I remove some of the values here, there's still nothing in the console because the type is currently not child list. Even though the observer will be detecting these changes, but the type is going to be character data here. Even up to this moment, it's still going to be character data. Okay, yeah. The reason why this is happening is because we removed the, I was expecting that until I cleared the li here, until I cleared the li until I clear the li, that's when we'll get this. But we're actually getting null here even before I clear the li, and the reason is because when I cleared the last letter here, the browser is going to automatically add a br tag inside the this in here. Let's see. As you can see, this second li here is having a br because there is nothing in the li at the moment, so the browser is adding a br automatically, and that's why we are having null. And the reason why it is null is because the br does not have, let's see, the br here, it does not have any previous sibling inside of this li. But when I now clear this li, now we are going to get li with the id of first as the previous sibling, because the previous sibling of this li here is this li here. But here, when the browser adds the br does not have any previous sibling because it's the only child node of this li, and that's why we're having null. So let me now remove this li here. Let's now check the browser again. As you can see, we have li with the id of first tongue, which is the previous sibling here, the previous sibling of the li that I removed. So I hope that's understood. You don't have to disturb yourself for this because I said it before that there are some the observer detects all of the changes, so it's very useful if you can manipulate the values returned by the observer. You can make some good things out of it. So the observer detects all of the changes. Just note that here the previous sibling is the li with the id of first in this case. Good. Now let's go back to the editor. Another property that we can access here is the attribute name and the attribute namespace properties. That is, we can say attribute name here, attribute name. As you can see, the attribute name, and we can also say the attribute name space. Now, the attribute namespace is only available when you are passing XML, like you are using SVG elements and you are using some custom attributes. SVG. If you are good at using SVG, you know that it's not just simple HTML. So that's when you can have something like the namespace. So namespace is only available in XML, not in HTML. So since we are dealing in HTML here, we are going to say attribute name in this case. But now, if we actually leave this code like this, we are never going to get anything in the console, even if we change the attribute, because we are saying, we are never going to get a real attribute name, because we are saying if the type is child list. So we have to change this one from being child list to attributes like that. So if the type is attributes, that is, if the observer detects a change in the attribute, log the attribute name, that is the attribute that was changed, log the name into the console. So let me now deactivate, let me uncomment this, set deactivate. Let me uncomment this. After 5 seconds, we are going to change the id of the li, first li in the UL, to list lm, which means that we are now going to get id. By that time, we are going to get id in the console because that's the name of the attribute that we are changing. Let's go into the browser and see what's happening. So let me refresh this, and now we can come here. Let's expect something here. Yeah, as you can see, we have this id here, And the reason why we are getting this ID is because we are actually changing the ID of the first li element inside the UL. So I hope that's understood. That's it for attribute name. And as I said before, attribute namespace is when you're passing XML, so you can actually access attribute namespace. But since we are dealing with HTML, what we have to use is the attribute name alone. And lastly, we can access the old value attribute of the mutation object like this. Now, okay, yeah, good. Now, as I said before, okay, yeah, the last property of the mutation object that we haven't talked about is the old value. And what does this give us? This gives us the old value of either the attribute or the character data. You know, as we said here in the option, character data old value true, attribute old value true. And as I explained in the previous video, I said this is going to make the observer store the old value of the attribute before it was changed, and this will also make this character data old value too will make the observer store the previous value of the character data before it was changed. So it's that simple. Now let's just say for character data, for character data, so we say if type is equal to attribute, or let's use or type is equal to character data like this. So if the type is attribute or the type is character data, that is when we want to log both the old value and the new value into the console. So let's just say console.log. Let's just say console.log the old value. So we say mutation dot old value like this. So what this does is that it checks if the type of change that was detected is the attribute type or the character data type. That is, if there was a change in the attribute, in the attribute, remember that the attribute we are changing here is ID, because we set the filter to be ID, so we can't even, the observer is not going to listen to changes in other attributes, so it's only going to listen for changes in the ID attribute. And here we are changing the ID after 5 seconds, so remember that. So if the type is attribute or the type is character data, console.log mutation.old value. So let's go into the browser. Let me refresh here. And now, okay, let me refresh again. So in the console, we get first here. Why? Because the previous value of the ID of the first li is first. Remember that I set that when I wanted to detect the previous sibling. So we are going to check that now. Now the previous ID is first, but the current ID we've changed the previous ID to, this first is now list lm. Sorry, let's check the DOM. As you can see, li id list lm. We changed this in our code. So if we also make a change, so let me just say, let me remove the e here. Now if I check the console, we have TONGUE, which was the previous value of the character data, because we actually changed the character data from TONGUE to TONGU. We remove the e, so the previous value, which is the old value that we are getting here, is TONGUE, like that. So here we come. Now let me just remove this. I just want to give you a quick tip here. So let me just say character data. Now if type is character data, we want to log the old value and the new value. So how do we access the new value? For character data, to access the new value, we have to first get the target. So we can say mutation dot target dot data, like this. And now that dot data there means we want to get the data. Remember that the target here, as I said before, if the type is character data, the target is going to be a text node. And when it is a text node, you can access the value of the text node by using the data attribute here. So you can call this you can access this data attribute on any text node, like that. So let's go back to the browser and let me refresh here. Currently we have nothing in the console. The console is currently empty. If I now change one of these values here, currently I have not changed anything, so the console should still be empty. Now if I change this one to nosy by adding y, you can see here that we have nosy. This nose is the old value. Remember that we said console.log the old value, comma the target data now, which is nosy, the current value, and the old value was nose. So like that. Go back into the editor. Now we are back in the editor. So also we can get the value if the type is attributes. This is just a hint that I just feel like giving. To get the current value, I mean the current value of the attribute, here we are saying if the type is attribute, that is if there was a change in the value of the attribute, we want to get the old value of the attribute. Then let me just say so I'm just saying the old value plus then this. Now to get the current value, we are going to say mutation.target. Remember that the target is going to give us which element, in which element the attribute was changed. Then we can now say dot get attribute, like this. And in this case we want to get the attributes that was changed, so we can now say mutation dot attribute name. Now what am I doing here? If you still don't understand, we are saying I want to get the current value of the attribute, so I'm saying mutation dot target, which is going to get where the attribute was changed, which is going to be an HTML element because the type is attribute here. Now when it is an HTML element, I can now say dot get attribute, which means I want to get the value of an attribute, like that. Now the parameter that this one takes is a string, and the string is going to be the name of the attribute that I want to get its value. And to know which attribute I want to get the value, I have to say mutation.attribute name. This is going to return the name of the attribute that was changed. We can now get the value using get attribute here. So let me go into the browser. Let me now refresh it. So we should get the old value and the new value in the console, because I'm sorry for that. So now we should get the old value and the new value in the console. Remember that after 5 seconds we are changing the ID of this first li here from first to list lm. So remember that. So let me now refresh it and we can now check the console. So after 5 seconds, let's see what happens. As you can see, we have first, which is the old value. We then have plus, then we have this list lm. So remember that first is the old value by when we said mutation.old value. So this is the value, mutation.old value, and this one we said mutation.target get attributes, and we passed mutation.attribute name to get the current value. So you can look back and see what we've been doing to understand it better. So I hope you get the point here. So now we are not going to get anything because we are checking if the type is attributes. So that's why there is nothing logged into the console even when I changed the character data here. Now I think that's it for now, and I'm going to add one more video. We are going to be creating a simple, should I call it a game? Maybe. So we're going to be creating a simple game, very simple one. We're going to be creating a simple game which is going to be like how should I describe it? We're going to have something like this. Then we will allow the user to actually complete the list of sense organs, because it's not just tongue and nose. There are 3 more organs to complete 5 lists, the list of 5 sense organs. So we're going to create a game like that. It's going to note whenever the user enters something. Maybe the user enters how should I say, the user enters the skin, something like that. We're going to create it in the next video, and whenever the user enters something, we check if it's one of the sense organs, and if it is, we're going to use mutation observers, just explore and see how we can manipulate things there and use it in a web application. So I'm going to end this video here for now, and give this video a thumbs up if you like it, and kindly, if you enjoy my content on this channel, subscribe to this channel and share the video with your friends. Thanks and bye for now.